This video will discuss two cloud concepts made possible by virtualization: pooling and elasticity. When we purchase server hardware, just like your desktop, in most cases the server is not fully utilized. This leads to wasted resources. We all realize that if we step away from the computer, it is not being used. But keep in mind that even when you are using it, if what you're doing is only using 10% of your CPU, your computer is spending 90% of every second doing nothing. Pooling is the concept which allows resources to be pooled and shared for multiple users. In other words, the CPU, storage, and networking are put into a big bucket to be accessed for different workloads. Because of pooling, if you allocate wisely, you can actually under-provision your resources to save money, knowing that all systems won't be used at the same time. In the traditional model, it can take weeks to procure a new server. This involves time online, designing the server, negotiating prices with the vendor, shipping, installing the physical hardware, and then installing the operating system and configuring the server. Other considerations include ensuring you have enough physical space in your data center to hold the server, ensuring you have enough power available, the right kind of power connectors, and making sure you have enough network connectivity available. If any of these considerations needs addressing, it can extend out your deploy time. When using virtualization, however, new servers can be created much more quickly, even minutes if created in an automated fashion. Servers can be built and changed as workloads increase or decrease. When demand goes up, new servers can be built, which can be destroyed when demand goes down. This is known as elasticity. One example of this is used in cloud deployments for websites. We might be able to easily predict the expected usage of a website. However, if a site were to go viral, elasticity would allow new servers to be built automatically, sharing the burden of the load to prevent an outage. This can also affect online retailers with seasonal bursts of activity. So how does this work? Consider this one server running along without an issue. The server is not being taxed very hard and everything is going along well. All of a sudden, our website becomes more popular. Perhaps it is because our product went viral, or perhaps it is nearing the holidays. We can see that it has an effect on our server as we see the usage of our CPU start to increase. Now things have gotten more popular, and our server is being taxed more heavily. Thankfully, we're using a cloud service and are taking advantage of elasticity. Our server has hit 80% CPU usage, and the hypervisor monitoring the computer has taken note. It builds another machine within minutes and adds it behind the load balancer. Now things are looking a little better. However, the popularity of our website continues to grow. Once we reach 80% CPU again, another server is built, and we can see that the load is back down. Note that we are now at a point where one server could not handle this entire load. If we had not done this, our website would be inaccessible. Sadly, all good things must come to an end. The mob has decided that our product is no longer exciting and has moved on to the next fad. Perhaps Christmas is over and the shopping boom has shrunk. Whatever the case, we can see that our CPU usage has dropped. The hypervisor has calculated that we could easily run at under 80% with only 2 servers. Therefore, one server is removed and destroyed. There is, after all, no reason to pay for a server that isn't needed. Finally, we can see that the usage has gone down enough that we are back to one server again, eliminating the need of the other 2, and thus saving money on resources. We can now see that this method is continually scalable, allowing us to go up to as many servers are needed to share the load.